Hi everyone, we're Team Clio, and we have a automating venue sanitation robot for our projects. So the main benefits of having this robot is the financial cost. Using this robot will allow you to be significantly cheaper than the current products on the market, which are just people that go around cleaning. Number two, it's very scalable, so you can easily extend this project by adding in more robots, which will like parallel with the other robots as you want to increase the number of robots you have. Number three, the intelligence. So we have a navigation algorithm that can efficiently like pick up trash and find routes that will clean up the field faster than a person probably can. And robustness. Yeah, so we make sure that our robot is able to sustain a lot of force to it and be sturdy built. So the approximate weight of our product will be about 35 pounds, and it can move at 5 miles per hour. And we have the battery chosen has about 10 hours of usage, which is enough for a full night of cleaning, which is the intended use. So going a little more into financial cost, we found that a rover is probably around $1032 one-time purchase versus having a personnel will be about $1416 per concert. And by concert, this is from desertoasiscleaners.com, which is the one of the contractors for the Coachella cleaning events. Yeah, so this robot has 107 tons of waste, which is a lot of work for humans to clean up. And with the uptick in number of concert goers, this robot definitely has a future in cleaning solutions. So yeah, a little more into the software components of our robot. For the prototype, we have a Raspberry Pi. It takes images from a frame and it sends it through to the different softwares on board. So it first goes into computer vision, which determines a boundary for where the trash is. It'll send into navigation, which is kind of the brains. So it combines like column navigation, which is long motor pattern, with just like searching and seeing which trash is within the column in order to move the robot into the most efficient navigation path. And finally, we do anticipate some human workers. So maybe just 10 robots, one human controls all 10. Because the robots are mostly autonomous, but it might be helpful for a human to just make sure that none of the robots ran into any issues, as well as monitoring the progress of the robots. And we have built this UI so that it is able to be manually overridden, as well as for the person to really quickly debug by like looking at which state the navigation is in, as well as how the bounding boxes are showing up. And the computer vision algorithm, which is one of the algorithms on board to detect the boundary box, as seen in the image on the left, you can see like a box around the sunscreen, which is trash. Yeah. Oh, that's our UI. Again, you have a camera, you have some status about the robot, and you have controls at the bottom. And this will allow you to manually override the robot's navigation. Robustness. So we have some hardware components. We have a sweeper, which we 3D printed at the Makerspace. We also have a scoop. So the sweeper will sweep the stuff inside. The scoop will launch it into the back container, which is a storage. We also ran a full assembly FEA to verify that the robot's able to sustain enough force to both the front, the top and the sides. So if a person decides to mess with the robot, it should be able to sustain that force for a little while. There's also there might be, so Coachella is mostly flat, and so we don't need to worry too much about like suspension and stuff like that. But we did want to just verify that if there is a little bit of hills in the terrain, it'll be able to survive that. Cool. Yeah, thank you so much for listening to our presentation.